actually going to start on the bottom of page 21, and we're going to use everything that we figured out the other day. So we found out that we had critical numbers from our velocity function at 0 and 4, and from our acceleration at 2. And basically what we want to do is just draw the pathway of this particle. So even though this question is not on here, what we're taking a look at is the position of the particle at 0, the position of the particle at time 2, the position of the particle at time 4, and because this time frame was 0 to 6 for the entire problem, we also want to know the position of the particle at time 6. So you use all of the critical numbers from both acceleration and velocity, okay, as well as the critical numbers from the time frame, 0 to 6. And what I did was I went ahead in my calculator, I went into y equals, and I put the position function into y equals, okay, so that this would be really, really easy for me to figure out. Okay, so when I go into the table, once you guys do that, what I'm going to do is just write down the position at time 0, which was 0, negative 48, negative 96, and this is back at 0. Okay, so first of all, these negatives, what does that mean?
Travel to the left.
Yeah, so in what we're talking about, traveling to the left. It could be down, though, right? Mm-hmm. Or backwards on an angle. So
relative.
That's right, it's relative. Our graph is just going to be left and right. Okay, so since I know furthest to the left is at time 4, which is negative 96, and then furthest to the right that I really need is 0, when I draw my line, which is basically going to be my scale, this is time 0, this is time negative 96, and then I have negative 48 here. All I'm putting on here are the times that are relevant to what I'm looking for. I mean, I don't know if this is an accurate distance. It's just a scale. It doesn't have to be 100% accurate. But what I'm looking for is my particle started here at time 0. And then at time 2, we saw that the position of the particle was here at negative 48. So I'm going to put time equals 2 here. Then at time 4, the particle was at negative 96. So this is time 4. And then at time 6, the particle was back here at 0. Okay, so all I did was put points on here because what's going to happen is, numerically, we went from time 0 to time 2 to time 4 and then back to time 6 here. So we're looking at the position of the particle over that time frame. So depending on what happens, this could be some crazy squiggle line, right? Or curve, because it won't be a line. But do you guys see what I'm saying? That's all you have to do. So you're looking at your times, which are your critical numbers from your velocity, your acceleration, and then the endpoints based on the time interval that they're looking at in the problem. Then you want to find out the position of the particle at those times by using your calculator, and then you're just drawing a pathway. Okay, does it have to be perfect? No. But does this kind of give you an idea? At time 0, we were at position 0, whatever that is. Then at time 2 at negative 48, meaning 48 meters, centimeters, nanometers to the left, whatever it is, and then so on up until time 6. We don't care about anything after time 6 because the time interval that we were given was 0 to 6. Questions? Okay, there is a question like this, and this is what it asks for on your homework for tonight. Okay? All right, so let's take a look. We are working again on rectilinear motion, so we need to be on page 22. Okay? And I'm actually going to give you about 7 or so minutes. You guys are going to do this question on your own. It is very similar to the bottom of page 21, and then we're going to go through it together. Okay? So we're looking at about, I don't know, 9:59, almost 10 o'clock. I'm expecting you to do this, please. So the only thing that is different about this question is moving to the left and moving to the right. And actually on page 21 we did talk about it. And we've talked about it a ton. Jay and I just talked about it. So while you guys are doing that, I'm going to hand out these quizzes. Remember, you need to give the other portion to your partner. And remember, not every page is going to be graded for you. Please do not discuss the quiz right now. You need to be working on this problem. You can talk about it later. guys ready? Even if you're not done, because maybe you got stuck, or you want me to leave you be? You want a couple more minutes? Just a couple more minutes? Okay. Okay, let's see how far we've gotten here. All right, so the first thing that we want to do is determine the time interval over which the particle is speeding up and slowing down. What do we need to do those two things? We need the what? I'm sorry? Yep, first and second derivative. Okay, so in part A, we need the velocity. So what's the velocity function? 12t cubed minus 12t squared. Okay, so then I need the critical numbers from here, correct? Okay, how would I go about doing that? Set the function equal to 0, and I'm going to have to factor. What should I factor? Okay, so we're going to take out a 12t squared, so that leaves me with what? T minus 1 is equal to 0. So my critical numbers here are what? 0 and 1. The biggest piece that I need to make sure that I remember here is because we're talking about time and they told me that time is going to be greater than or equal to 0, this is pretty much my endpoint, right? On the left. Okay, then I need my acceleration function. What is that? 36t squared, minus 24t. Okay, so I need to set this equal to 0. Can I factor anything out? Okay, so let's take out a 12t, leaving me with 3t minus 2. So we have another critical number of 0 and 2/3. Okay, so 0 is already taken care of, correct? Yeah. Okay, so we're going to go down here on the bottom. We've got 0 here, 2/3, and 1. Is that all I can do for now? Okay, so we have velocity on the top and acceleration on the bottom. Okay, so what are we going to plug in here? 1/2? Yeah, okay, so let's start with the velocity. So when I plug in 0.5, this is positive, this is negative, so this is what, negative? What about here? What are we going to plug in? 0.75? I mean, either way, what's going to happen? 0.75, whatever it is squared, it's still going to be positive, right? 0.75 minus 1 will still be negative, right? Okay, and then what, 2? So this would be what, positive? These are all velocity. So now let's plug in the same things but use the acceleration. So this is 0.5. So is this going to be positive or negative? This is positive. 0.5, so half of 3 is 1.5 minus 2. Is this positive or negative? Negative. Okay. 0.75, same thing. So what's going to happen? Did anyone use a calculator to figure this out? Well, 0.75 times 2 is what? Okay, so then does this go up when you multiply it times 3? I'm just trying to figure out. Either you can use a calculator here or you did it in your head. But what does the sign become here?
Positive.
It's positive. Okay, and then if you pick 2, what happens? Positive. Okay, so in this case, when we're taking a look, we want to know where the particle is speeding up. So the particle, wow, is speeding up where? Thank you. 0 to 2/3. Anywhere else? Yeah, and 1 to infinity because we don't have an end time at this point. And if we had to give a justification, what would it be? Do I just write same signs? I would have to be very specific, right? Acceleration and velocity have the same sign. That's your justification. Okay, and then the particle is slowing down where? 2/3 to 1. Why? Because acceleration and velocity have different signs. Is it just Monday, rainy? Oh, come on, people. 5 odd days. Come on. It's good news. It's a good news kind of day. Wow. I got nothing. All right, B. We want to identify when the particle is moving left and moving right. Okay, so is this based on acceleration, velocity, position? Like, how can I tell? If you looked in your notes, Jay's taking a guess. Yes, sir.
Velocity.
Yeah, we have to look at our velocity, and really we're just looking at the signs, right? Negative is which way?
Oh, I knew that.
Yes, you did, because we just talked about it. Okay. So if this is 0 and this is infinity, our critical numbers are 0 and 1. So from 0 to 1 for velocity, this was negative, correct? Okay, and then from 1 to infinity was positive. True? And I'm just getting this from here. I didn't have to do any extra work. It's like a BOGO, right? Buy one, get one. Free. You already did the work. Okay, so what do I have here? If I were to say the particle is moving left from when to when? When's particle moving left, folks? 0 to 1. Okay, why? Because velocity is negative. You could say because v of t is less than 0. Less writing, right? That's your justification. Okay, so then if I were to be talking about the particle moving right, we would say from 1 to infinity, because we don't have an end time at this point. And this would be because v of t is what? Greater than 0. Okay, part C. We want to find the total distance traveled from times 0 to 3. So I have some critical numbers from both velocity and acceleration. Am I using all of them? No. Ben is saying no. Jay is saying no. Which one do I use? Velocity, acceleration. Which one? Velocity. Okay, so that means I need to take a look at my number line, and they're going to 3. So this is going to 3. Okay, So I'm just using this number line here, but I can make another one. This is 0, this is 3, this is 1. So we know that velocity, which I've done this now for the third time, negative, positive. Okay, so remember distance traveled cannot be negative, true? Okay, so we need to figure out what, let's see, absolute value of s of 1 minus s of 0. And we're going to add that to the absolute value of s of 3 minus s of 1. What would be helpful to do here?
Have a calculator.
Absolutely, use my calculator. Did anyone get this distance right here?
It's just
It's just what?
absolute value.
Bless you. It's absolute value of negative 1, so this is 1,
Yeah.
right? Plus, what's this?
I didn't want to do it on paper. It's something.
I got this is 135 minus a negative 1, so it becomes plus, right? So this is 136.
Oh, yeah.
So my total distance traveled is,
137.
nice, 137 units. Meters, centimeters, nanometers, whatever. Okay? Questions? This is important. Okay? All right, and then the last one, D, displacement. How do I find it? And it's more specific. It says, find the displacement from time 0 to time 3.
Calculator.
Okay. I'm just using what?
And from beginning.
Just use the endpoints. Am I plugging into the position, the velocity, or the acceleration? Yeah, position. It's a displacement. Where did it start, meaning the particle or whatever we're talking about, and where did it, the particle, whatever we're talking about, end? So it's s of 3 minus s of 0. You guys told me s of 3 was what, 135 minus s of 0. Okay, so it's 135, whatever the units are, right? Okay, questions? So this is pretty much a review of what we did last class. Okay, and that would be an entire problem. It could be an entire problem. Okay. So the next thing we're going to talk about, and the steps are here and the problem is on the next page, is to find the maximum or minimum speed. So the first thing I want to ask you is, if I give you a function, f of x, and I were to ask you to find the relative max or the relative min, what would you do? This is a review.
See.
Find the derivative. Okay, so when we're talking about a max or a min of any kind, whether we're talking about speed or acceleration, to get a max and a min, you have to take the derivative of whatever you're being asked to find the maximum and minimum of. Does everyone understand what I'm saying? So if I ask you to find the speed, how do I find the speed? What is it? We talked about it last class. It's the absolute value of what? The velocity. So how do we find the velocity? First derivative, and then what do I do with that first derivative? Not yet. Absolute value. Yes, yes. You're a couple steps ahead of me, but you're still on the right track. Speed is the absolute value of velocity. True? Okay.
Yeah.
If I want the minimum or the maximum, you just told me that no matter what, I have to do what? To find a min or a max, take the derivative. So that means I'm going to have to take the derivative of this. Do you see what I'm saying? So it's okay. It's going to be okay, I promise. All right, so here it says take the absolute value of velocity, right here. Take the absolute value of your velocity. This is our speed function. Then we have to find the derivative of the speed function. So really what you're doing from your position is taking the derivative twice. Okay, that's shorthand. You're taking the derivative 2 times. We will find the critical points, okay, just like we've done before, as alluded to by Jay. Okay, and we will substitute, this is key, back into the speed function. This should make sense. The largest value is the maximum speed, the smallest value is the minimum speed. Okay? This is important though, because you need to know what you're doing. Everybody good on the steps? We're about to do a problem.
Let's go.